This video is on naming alkenes, and you should follow along in your note packet and take down any information that you need in addition to what I've already written for you. So in terms of an alkene is different from an alkane because an alkene will have at least one double bond. If it has only one double bond, then the formula would be CnH2n. And some common examples are C2H4, ethene, and C3H6, which is called propene. Sometimes you'll hear them referred to as ethylene and propylene. Those are kind of common names. Alkenes are named very similarly to alkanes, but the difference would be that you would have a suffix of ene, instead of ane. And another major difference is that you will have to tell the reader where the double bond is located. And it's the double bond's location that is the most important as you go through these. So if we look at the rules for naming alkanes, the first thing you'd want to do is determine the longest continuous chain of carbons, but this time they have to contain the double bond. So the parent chain has to have the double bond. Then you're going to number the carbons so that the double bond would have the lowest number. Okay, so if it was in the 1 and 2 carbon, we would call it a 1 location because it's implied that it's also between 2. If it were between 2 and 3, we would call it a 2 double bond because it's implied that it's between 2 and 3. So it's the location of the double bond that matters the most. We want the double bond to have the lowest number, not any branching. The branching will fall off after the double bond has been located. So if you look at the first example that I've given you, drawing a structure for 1-butene. If you want to try this one right now on your own, you could pause the video and then just check and see if you are correct. But what you would do is you would first look at the prefix but, okay? And going from what we learned previously, but means that there are 4 carbons. So you could draw yourself 4 carbons, and you could draw them all with single bonds to start out with. Now, when you look at the name, ENE means that there will be a double bond. And this is telling you that it's located on the 1 carbon. Now, if we want to start with this carbon as being the 1, then we would call that 1-butene. And now your next job is to just fill in the H's with what remains. So if you look at this first end carbon here, it's already making a double bond. That means it has room for 2 single bonds or 2 H's. When we move over to this second carbon, there are already 3 bonds being made, so there's only 1 H available here. Then H2, and lastly H3. Now, if we were to draw that expanded, we could easily draw this here, remembering that when you have a double bond, the geometry around the double bond is that it is trigonal planar. So in real life, if you were to draw this molecule, you would actually get a shape something like this. So this is really what it looks like, but we can draw a condensed formula up at top. So that's 1-butene. Now, I have quite a few more practice problems for you to try. So the next one is to name the following. Again, if you want to pause the video right now, try it yourself, and then just check and see if you are correct. You can do so. So the first one, the first thing you want to do is find the longest chain of carbons that contain the double bond. You can do this chain right here, or you could have started at the bottom and worked your way up. Either way, you could number these carbons 1, 2, 3, and 4. So we know that the parent chain, that parent chain is a butene. So we would put butene as the root name for the compound. Now that double bond locates between the 2 and the 3, so we're just going to go with the lowest number there, a 2-butene. And if you look off of that parent chain, there's also a methyl group hanging off of that number 2 carbon. So we would say 2-methyl 2-butene. And just remember with those compounds, we would want to make sure that we're separating numbers and words with dashes. All right, on the next one, it says to draw a structure for 2-methylpropene. And again, if you want to try these yourselves, pause the video right now. If you are willing to, if you want to watch it along here, prop means that there are 3 carbons, 1, 2, and 3. Now, no matter where I put the double bond, if I put it here, it's located between the 1 and the 2. If I change the position of that carbon, and here, put it there, it's also still between the 1 and the 2. So it really makes no difference where you put that, and that's why you don't see a number in front of the prop telling you where it's located, because it can only be located off of the 1 carbon. So then you would go on to the 2 carbon and put a methyl group, which we learned yesterday as CH3, and then you would do the same thing filling in your H's. Here we would have 2 more H's. Here we could have no more H's because we're making all 4 bonds, and here 3 more. So now you've drawn a structure for 2-methylpropene. And then this example, drawing 2,5-dimethyl-2-heptene. If you want to try that one now, you can pause the video and see how you do. Hept means that there are 7 carbons. So I'm going to draw 1, 2, 3, 4, 5, 6, and 7 carbons. Now, this ene is telling me there's a double bond on the 2 carbon. So if I number it from left to right, 1, 2, I'm going to draw my double bond between 2 and 3. It's also telling me that there are 2 methyl groups. One is located on the 2 carbon, the other one is located on the 5 carbon. So I'm going to count over 1, 2, and I'm going to draw a methyl group here, 3, 4, 5, and I'll draw a methyl group here. Now remember, it doesn't matter if you go up or down with those methyl groups at all. And then what you want to do is fill in the H's so that everything has enough. If you look at this end carbon, it can have 3 more H's. If you look at the second carbon, it's making 4 bonds already, so that one's full. This one has room for 1 H, 2 H's on this C, only 1 H on the next one, 2 H's on this 6th carbon, and 3 H's on the 7th. So there you go with 2,5-dimethyl-2-heptene. Now you might have noticed we skipped one problem in your notes, and that's because I'm going to come back to it in just a moment. All right, the reason we skipped that problem is because it relates to something we're talking about now, which is called geometric isomers. And a geometric isomer is possible only in alkenes, so only in compounds that have double bonds, because you cannot rotate around a double bond. And I can show you this in class. But what we're looking at here is 2 different isomers, cis and trans. Cis is when the H's are on the same side of the double bond. And trans is when the H's are across from each other. Now, a lot of times students will ask, what happens if I have H's like this with X groups over on the other side, kind of more separated like left and right? And generally speaking, although that can happen, we wouldn't probably call them cis and trans. They would just be, because there's no other H's here, so we wouldn't have to worry about this. Now, if we name that one example that we skipped, if you look, the first thing you'd want to do is still number the carbons with the longest parent chain. So I'm going to draw a line, remembering that that parent chain has to contain the carbon with the double bond. And then I'm going to number it so that the double bond has the lowest possible numbering system. So I'm going to start at the right side and number 1 through 7. Now, if you look at the parent chain, we have a methyl group hanging off of that carbon there. The parent chain had 7 carbons, so we would start with that prefix hept. And since it has a double bond, we would change the ending to ene. That double bond lives between the 2 and 3 carbon, so we will call it 2-heptene. And because these H's are on the same side, we would say cis 2-heptene. And lastly, we have a methyl group, hanging off the 4 carbon. So we would say 4-methyl cis 2-heptene. The cis, I've seen this done different ways. Some books will put the cis way out in front of the name. IB generally puts it right before the location of the double bond. So that's what I'm going to do so that you're used to that. But you might see it other ways when you're looking at other books. So if we practice a few more of these, name the following. Again, if you want to pause your video at each one of them, you certainly can. But looking at that one, you'd have a 2-butene 4-carbon parent chain. The double bond is between the two. Since the H's are on the same side, this would be cis 2-butene. If you look at the next one, you still have a 4-carbon parent chain. The location of the double bond is still 2, but because those H's are across the double bond from one another, we would call that a trans 2-butene. And that's where that name for trans fats comes in. Cis 2-pentene, if I were to draw pentene, I would draw the 2-carbon between the 2 and the 3. Now I want the H's on the same side. So I'm going to put the H's down on the same side. They could easily have gone up. And I'm going to count 1, 2, 3, 4, 5. So you've got cis 2-pentene, and then our last one would be trans 3-hexene. Hexene means we're going to have 6 carbons. The double bond is going to go between the 3 and the 4. So I'm going to have 2 carbons going this way. And you can figure out your H's easily afterwards if that makes more sense to you. Since it's trans, I'm going to put the H's on the opposite side from each other. 1, 2, 3, 4, 5, 6 carbons total. And that's how you'd name trans 3-hexene. And that brings us to the end of naming alkenes. Good luck.